Hello math students, today's video is lesson 5.1 trigonometry review. In this lesson we are going to review what we learned last year about trigonometry so that way we can use it as we go throughout the next few units. The first thing that I want to do is I want to start off by defining trigonometry. So trigonometry is kind of a big word, but it's actually fairly simple. Trigonometry is simply the study of the relationships between the sides and angles of triangles. That's really all that trigonometry is. If you remember from last year, we learned about sine, cosine, and tangent, as well as cosecant, secant, and cotangent. This year, we're only going to focus on sine, cosine, and tangent, as well as their inverses. So first off, we've got three basic trigonometric ratios. With each of these, my answer is going to be a number. So it's just a number. That's all it is. Usually you'll write it as a fraction or a decimal. First one that we've got is sine. So if I write it out, it's just sine. The symbol that we're going to use is, or our shorthand, I'm going to say sine theta. So that little circle with a line through it is the Greek letter theta. It is used, or Greek letters are used a lot in trigonometry. So the way that I'm going to define sine of theta is I'm going to say sine theta is equal to the opposite side. So the side opposite of theta divided by the hypotenuse. What this means is if I have a triangle, or specifically a right triangle like what I have drawn here, I've got my theta is just any angle. The opposite side is what it sounds like. It's the side that is on the opposite side of the triangle. So usually I will draw an arrow from the triangle or from my angle, and whatever side the arrow points to is the opposite. The hypotenuse is always the longest side. The next one we have is cosine. So the shorthand way or symbol for writing cosine is just cos theta. And then my definition, I'm going to say cosine of theta is equal to the adjacent side divided by the hypotenuse. So adjacent, that word means next to. So on this triangle, the adjacent side is the side that is next to my angle. Or if you don't remember that, you've got opposite and hypotenuse already. Adjacent is the side that's left over. Our last one that we have is the tangent. We write it as tan theta. So this is saying the tangent of theta, some angle. And our definition is tan theta is the opposite side divided by the adjacent side. So, a couple things. First off, theta, this right here is always an angle. So just keep that in mind. The only thing that you can ever put into one of these three trig functions is an angle. You can't put just any number, it has to be an angle. Another thing is that I want to talk about is a way to remember these. You may have heard of SOHCAHTOA. This is just saying, so if we have SOHCAHTOA, so we've got the sine is the opposite side divided by the hypotenuse. Cosine is the adjacent side divided by the hypotenuse. Tangent is the opposite side divided by the adjacent. Okay, the next thing that I want to talk about are the inverse trigonometric ratios or functions. So with these inverses, your answer is always going to be an angle. So it'll be an angle no matter what you put into these inverse trig functions. So let's say that I have the trigonometric function y is equal to sine of theta. If you remember from Module 1 when we learned about inverse functions, one of our properties is that x and y are switched. So I can say then that theta is equal to the inverse sine, and the way that we'll usually write it is this little sine -1 of y. And remember that y is equal to opposite over hypotenuse. We have a similar thing for cosine and tangent. So if I have y is equal to cosine of theta, that means that theta is equal to the inverse cosine of y. And then if I have tangent, y equals tangent of theta, I can say that theta is equal to inverse tangent of y. And all these are still going back to that same triangle that we had, where I have theta with my opposite side, the adjacent side, and the hypotenuse. One thing to note about opposite and adjacent and hypotenuse, and we'll talk about this a little bit more in a few minutes, but opposite and adjacent are going to switch based on what angle you're talking about. So if I was referring to this angle on top, the opposite side is going to now be where the adjacent of theta is, and the adjacent is going to be where the opposite of theta is. However, the hypotenuse will always be the longest side, or the side that is across from the right angle. So let's go through some examples of using these trig functions in various ways. But before we do that, we need to review the Pythagorean theorem. This is a theorem that talks about the relationship between sides on a right triangle. So if I label a triangle with sides A, B, and C, where C is always the hypotenuse, then I can say that A squared plus B squared is equal to C squared. And this right here is only for right triangles. When you get to pre-calculus, you will learn about how we can extend this to apply to different triangles besides right triangles. So some examples. First, this says find the sine, cosine, and tangent ratios for angle A and angle B in the triangle below. Well, on this triangle, I only know 3 sides. So the first thing that I need to do is I need to find side C. So my Pythagorean theorem says that a squared plus b squared equals c squared. Fortunately for us, a, b, and c are labeled the same way as they are in the Pythagorean theorem. So we don't need to worry about making sure that we've got a, b, and c in the right spot. So I am going to say here a squared, which is 4, plus b squared, which is 3, is equal to c squared. So all I have to do now is simplify both sides here. So 4 squared is 16, 3 squared is 9, 16 plus 9 is 25. To get rid of the square, I'm going to take the square root. Normally when you take a square root, you have to do plus or minus, but because we were working with triangles, and these are side lengths, you can't have negative side lengths. So I'm just going to say that C is equal to 5. Okay. So now that I know this, I can find sine, cosine, and tangent for each angle. So I'm going to start with angle A. So in order to find those trig ratios, I need to know opposite, adjacent, and hypotenuse. Well, opposite is always the side that's opposite from the angle it's across, but I'm going to say it's just opposite for A. The adjacent is the one that's next to A. And then tangent, not tangent, hypotenuse is the longest side, or the side that is across from the right angle. So if I want to find sine of A, that is the opposite side, which is 4 divided by the hypotenuse, which we found was 5. So that would be my answer for sine A. Cosine of A, this is the CAH, or CAH, is the adjacent, which is 3, divided by the hypotenuse, which is 5. And then tangent is the opposite, which is 4, divided by the adjacent, which is 3. So that's sine, cosine, and tangent for A. Okay. So now I want to do the same thing for angle B, but my opposite and adjacent are switched. So if I'm looking at angle B, the opposite is now the 3. The adjacent is the 4, but the hypotenuse is going to stay the same because it is always the longest side. So I can say that sine of A is equal to opposite over hypotenuse. And so we're doing B. So sine of B is opposite over hypotenuse. Cosine of B is adjacent over hypotenuse. Tangent of B is opposite over adjacent. One thing that you should notice is that sine and cosine switch based on what angle we're using, which makes sense because the opposite and adjacent switch. And you should also notice that the tangent of A and tangent of B are reciprocals, which should make sense because opposite and adjacent switch. So I'm going to go over 2 more examples of how we can use these ratios to help us find missing information on triangles. So number 1 says find x on each triangle below, and then I want to round to the nearest thousandth. Remember, thousandth is 3 decimals because the number 1000 has 3 zeros. So I give you an angle measure, and then I give you a side of the triangle, and I want you to find a missing side. So let's start by looking at what information we know. So I have my angle is 52. This x is the opposite side. The 3 is the hypotenuse. So I know opposite and hypotenuse. Which means that we're going to use sine. So I'm going to set up my ratio. I'm going to say sine of theta, which in this case is 52 degrees, is equal to opposite over hypotenuse. So now I have an equation where I've got just one unknown. So I need to get rid of this 3. Since I'm dividing by 3, I can multiply both sides by 3. And now 3 times sine of 52 degrees is something that you can plug into a calculator. So when I do that, I get for my answer x is equal to 2.364. And that is the length of that missing side. So if I had given you the adjacent and the hypotenuse, we would have done the exact same thing except for we would have used a cosine ratio. And if I had given you opposite and adjacent, we would have done the exact same thing except for we would have used the tangent ratio. Another thing that I can do is I can find missing angles using those inverse trig functions we talked about at the beginning. So let's start by seeing what information I know about this triangle. Well, I don't know anything about the opposite. It wouldn't be that hard to find, but I want to make things as easy as possible. But I do know the adjacent side, and I know the hypotenuse. So using with this information, that means that I am going to want to use cosine. So if I was just wanting to find cosine of theta, I would say cosine theta is equal to adjacent over hypotenuse. But I don't want to know what cosine is. I want to know what is that angle equal to. So we're going to use our inverse trig ratios, which is basically just switching the x and the y. So I'm going to say theta is equal to the inverse cosine of 12 over 13.7. And I want to put it in my calculator as the fraction and not as a decimal approximation. And so I get, when I plug that in, I get that theta is about 29 degrees. The last thing that I want to talk about is dealing with square roots. So this will come up when we're using the Pythagorean theorem a lot. So I want to talk about how to simplify a square root. So square root of 48, what I'm going to do is I am going to make a factor tree of 48. I'm going to say, well, what can I multiply to get me a 48? Well, 48, I could say is 2 and 24. Well, 24 is 2 and 12. 12 is 2 and 6. 6 is 2 and 3. So I have on here, I've got 2 2s, 2 2s, and a 3. So 48 is really the square root of 2 squared times 2 squared times 3. Well, I can take a square root and I can write it as, there's multiplication in the square root, I can write it as multiple square roots that are multiplied together. So square root of 2 squared times the square root of 2 squared times the square root of 3. Well, the square root of 2 squared is just 2. Square root of 2 squared is also 2. And then I have the square root of 3, which means the square root of 48 is just 4 times the square root of 3, which is a simpler way of looking at that square root. If I have the square root of 72, I can do the same thing. Well, I know that 72 is 8 times 9, and I can break each of these down. This is 2 times 4, 2 times 2, and then 9 is 3 times 3. So when I'm simplifying a square root, there's really a 2 right there. I'm looking for groups of 2 because if you square root something that's squared, it cancels out. So if I come back to the previous example, I ended up at this point with the same numbers that I had in each of those circle pairs. So I could even skip all of that and jump straight to this section right here. So on this example, I have 2 that's circled and 3 that's circled. So I can say square root of 72 is 2 times 3. This 2 that's left over doesn't have another 2. If we come back to our previous example, this 3 down here didn't have a partner, so it stayed under the square root. So I have 2 times 3 times the square root of 2, which is just 6 times the square root of 2.